Hello, and today I want to talk to you about multiple reflections. Okay, here I've got a 1 cent coin, and I'm going to hold a mirror against it. And no matter what way you orientate the mirror, it'll always only ever have one reflection. Now, something different happens, of course, when you bring the coin between two mirrors. And I think you can probably see about 5 reflections, and the closer you bring the mirrors together, the more reflections that you should be able to see. Now, the second thing about using mirrors just with basic reflection is that whenever you're looking at a reflection of an object, the reflection looks like the object in its shape, in the position of the different features, in its dimensions, and in every way except that it should be reversed. And in an Irish cent coin, we can see that the harp has been reversed, and the writing appears on a different side of the harp. Okay. And when you're looking at then the multiple reflections, just to bring those back, okay, you'll see that we have reflection, and we can see that which reflection is the reflection of another one by looking at how the coin has been reversed a second time and the third time and so on. And it looks as if the coin has been reflected inside the mirror. That's the appearance of it. And of course, the whole attraction of mirrors with children is that it's counterintuitive. Mirrors are, the way that they operate is based on the fact that light travels in a straight line. And we're probably all used to having done a very simple practical in junior cert, where we would take 3 cards with a hole in it, and we would put a candle or a torch, and we'd be able to see the light through the 3 holes, but only if the 3 holes were lined up. Another observation is that if we look at the shadow of an object, if you have strong light, the shadow of the object that has been cast is the same shape and size if the object is close to whatever the screen happens to be. So if I have a shadow of my hand, what I find is that if my hand is nearby, is that the shadow is almost identical to it in shape and dimension. However, if I angle the light source, or I angle my hand, then the shadow starts to be distorted. Okay. So these are all features of the fact that light travels in straight lines. And then the consequence of all this is that, as well as being able to see shadows and see reflections, the very fact that we can see is based only on the situation that light travels in straight lines. And if you didn't have light traveling in straight lines, we wouldn't be able to see clearly, we wouldn't be able to have our normal vision. Because remember that the light is a mere receptor of light, and then our brain makes sense of it based on its learning to deal with light traveling in straight lines. That our brain creates a conscious image only because it has become accustomed to that. So, to sum up, all of these different situations, play with shadows, play with mirrors, the concept of reflections and so on, all are based on one central concept, which is all you ever need in a good science lesson, is one single central concept, and that is light travelling in straight lines. Now, when we're looking at the mirrors and the coins, and if we look at, again, one single mirror here and one coin, alright, and we notice that the coin is about 2 centimeters away from the mirror. Now, not only is the image reversed, but this the reflection appears to be inside the mirror, inside a virtual world, at the same distance. So the coin appears in the reflection to be 2 centimeters away from the inside of the mirror. Of course, it isn't. It's only a light, a sensory impression of what's happening. But that's just another feature, is that there's an imaginary or a virtual distance, and that the object that is producing the reflection is seems to respect that kind of virtual distance.